Parallel connection is very okay. Can this device be parallel? Before I give you the answer to this question, I will let you understand what this device is used for. We mostly know this as voltage guard or AVS, automatic voltage system. And what is the aim or the purpose of this? Now, most people know this guy with one purpose or one aim, which is to protect our home appliances from high voltage and from under voltage from the grid or from the generator. But there are other two things which this guy does, which most of us don't pay attention to. Number one of the thing is this guy can serve as energy meter. Yes, though it doesn't have the ability of recording or keeping data of how much energy you consume per day, but at the very moment you are using it, it will tell you how much energy you are draining from your grid or from your generator or even from your inverter. Another thing is that this guy also serves as overload protection circuit or overload protection breaker. Yes, if you install system in a family house where you have a lot of children, a lot of people moving around, this guy will decide to on this without telling you whatever he puts on. You can use this guy to protect your inverter from over voltage, which we know is one of the reasons that gets most inverter damage. So this guy will protect your inverter from overload. Yes, because you can decide to select the amount of current you want flowing through this very device. This is a 63 amp voltage guard. You can decide to set it to 10 amps or even to 5 amps, meaning if you set it to 5 amps or 10 amps, if anything above that wants to pass through this very device, it will trip itself off, protecting itself and protecting your very inverter. So aside protecting your home appliances from over voltage and under voltage, this can serve as energy meter and this can serve as overload protection for your inverter. So can this be parallel? Because it has become very difficult for us, most technicians, to get hold of a single 80 amps or 100 amps of this very device. Most of the ones that are available in the market are either 63 amps or the 63 amps. So can we parallel this? Let's try it out. But the answer to the question is yes, it can be parallel, because this device at the output point have a reverse protection diode that will not allow the output voltage, to flow back into this very device. So let's try it out practically to see if this device can be parallel or not. We have our devices ready. We have our voltage guard, and we have two of them. We have our plier and we have a screwdriver, which we are going to be using. So the next thing we are going to be doing right now is to parallel these two guys together. Let's go. And remember, neutral is common. Yes, so when you loop the neutral at the input point, there is no point looping the neutral at the output point, because neutral is common. Yes, so the only thing you loop at the output point should be the live, because once you loop the neutral at the input point, it means you have already looped the neutral at the output point. So let's go. You can see everything is successfully looped. We have looped the two inputs together. That's the input of this is looped to the input of this. The output is yet to be looped. Why? It is because we are going to test it out to see how it's working normal before we loop the output, in case if there is any fire hazard or fire outbreak. You understand? So let's test this out. I'm done with the looping of the inputs. Both inputs are looped together and is connected to the socket. Now let's put the socket on and see what happens. We are yet to do the looping at the output. Both voltage guard came up at the same time and they'll click at the same time because they have the same timing. Yes, if you time this guy to be 10 seconds and this guy to be 5 seconds, this guy will come up first, this one will come up later. So, but if they have the same timing, they'll come up at the same time. Now let's loop the output. In case of fire hazard, don't run, you that you are watching. Call 911 or call 112. So let's try this out. So make sure you observe polarity. And like I said earlier, there is no point looping the neutral because neutral is common. What we are going to loop at the output point is just the live. So you have to observe polarity. Let's go. No spark. It means the reverse protection diode is working very fine. Now the question that will be running through your mind is, how are they going to do the load sharing? And that's what we'll be doing right now. Let's check it out. Let's see how they will do the load sharing, right? So I have this very cable, is my TV cable. I'll plug my TV to this. I don't want to use LED because the load will be insignificant and we will not know the amount of current flowing through these guys. This is my TV, my TV cable. Yeah, Don't laugh at my TV cable. So let's connect our TV cable to see how much amount of current that will flow through these guys. Sorry, I don't want to get shocked though. That's why I'm being careful. Because I don't have milk at all. Okay, it's like my TV is on standby. Let me get the remote. And I think that's the reason why both voltage guard are reading 00. This 2 digits here will show you the amount of current you are draining from each voltage guard. Our TV is on. Let's see how much energy will be coming out from each of these breakers. Okay, I think the amount of energy is still insignificant. Let me get something that is more heavier. Let's see. Let me get something that is a little bit heavy. I'll be back. Since I couldn't get hold of a heavy appliance, a single heavy appliance, because most of my home gadgets here are actually energy efficient, I decided to put everything on. The TV, the sound system, one charger is there, this pressing iron. I didn't put the fan. So let's check this out to see if this parallel connection will work very well or not. So I'll put the socket on now, and our socket is on. The TV guard is on, or they are on, right? So they have given output. You can see from here we are consuming about 0.7 amps. I bet you it's more than 0.7 because this guy also is contributing from its own end, which is not displaying on the screen. But let's check it out now. You see that's about 0.8, right? Let's put this off to see if there is contribution from this guy or not. So you can see there is contribution from this end, because immediately I put this guy off, this one decided to push up more current from its own end. So let's put this guy back on to see what happens. You can see there is a drop, so it means this guy is contributing about 0.6, which is not up to 0.7 that will display on the screen. Now let's put this guy off to see if this guy will contribute from its own end. So this other guy is off, and you can see we have about 1.2 amps here. So the parallel connection is very much correct, and everything seems to be working fine. There is no reverse of voltage, there is no reverse of current. It means you can parallel 2 or 4 voltage guard together and they work perfectly fine. You can see, right? Everything is working very fine, and that is from this very guy. Now we have about 1.2 here, and if you put this guy on, it will reduce. You can see it. It means the parallel connection is very okay. So if you are a technician or solar installer that have been having difficulty in getting a single 80 amps or 100 amps of this voltage guard, you can actually parallel 2 or parallel more to get the results you are looking for. These experiments have proven that you can parallel 2 voltage guard or more together to get a result. So the conclusion of the whole matter is, after this experiment, it have proven that you can parallel 2 or more voltage guard together to get a very good result. You don't have problem with that, and you are welcome. Don't forget to subscribe to my channel. Don't forget to put on your notification button. I am your favorite solar energy guide, your Solargod.